Right, so today I'll be speaking about, well, it's more of a study thing. I'll give you an idea of how I tend to go about things in terms of research and understanding a few new concepts, theories, and of course, real life examples to help me understand said theories and ensure that at the end of the day, these things make sense. So, my primary interest actually lies with navigation, hippocampus, and computational neuroscience. I enjoy understanding how the brain is able to map its surroundings and other aspects of our visual system and oculomotor system. So, something in cognitive neuroscience, especially those who study perception and attention, they study a thing called object avoidance. Now, the idea of object avoidance is that essentially when an animal or an organism is going somewhere, for example in a maze, going from point A to point B, there will be certain points in that maze that the animal will avoid and move to another position, and that position will eventually lead them to their goal. And the object doesn't necessarily have to be a fixed object, it can be fluid. It can also be a distracting object as opposed to an object that is permanently fixed. So I'll give you an example. The most well-known and simplest example is Morris's water maze. So essentially it's a round tank filled with water, and chalk, sometimes milk, is added in the water to make it translucent, essentially. Well, not really, make it very opaque. But the rat that is the subject, the goal of the rat is to find a platform so it's just above the surface of the water, and that will obviously avoid any situation where it might be drowning. So although the mouse is not exactly avoiding the water or the fluid, it's going towards a goal, which is safety, and safety is only possible by a raised platform. So when I came across that, I was like, this is really fascinating. And then, long story short, came across many different concepts, one of them being computational neuroscience. So this will be one of many situations where I'll be sharing some books I'm reading, and of course do my best in defining these things. So we'll be focusing on that, and also the vestibular system, and understanding that in as much detail as we possibly can. So let's double check here. Right, so first of all, we have to begin by definitions. That's the most important thing, which is first and foremost, what is computational neuroscience? Pardon me. Well, Right, so that is understood in the following manner, right? So what I'm going to do is simply search computational neuroscience APA. So this will give me a nice definition. So, computational neuroscience, also known as theoretical or mathematical neuroscience, study of the nervous system using mathematical models, computer simulations, and theoretical analysis to understand the principles governing its development, structure, physiology, and cognitive abilities. So, it's very rich in understanding mathematical laws, mathematical principles, and developing models and testing those models, as well as steering them in directions where they weren't meant to go. It aims to uncover how the brain processes information, including how it learns, makes decisions, and performs other cognitive function. Here's a more detailed breakdown. Focus on modeling and simulation. Computational neuroscientists create mathematical models of brain structures and processes, then use computer simulations to validate and refine these models. So, mathematical models, as I mentioned, are key to understanding brain structures and processes. Then use computer simulations to validate these models. Interdisciplinary approach. This field draws from various disciplines including neuroscience, computer neuroscience, mathematics, and physics to address complex brain functions. Emphasis on biological plausibility. While it uses computational tools, computational neuroscience strives to create models that are biologically realistic, focusing on how neurons and neural systems function in the real world. Distinction from other related fields, it differs from connectionism, machine learning, and artificial intelligence, which may use less biologically plausible models to achieve specific cognitive tasks. Now, the goal is to understanding brain function. The ultimate goal is to understand how the brain works at various levels, from individual neurons to complex cognitive processes, by identifying the computational mechanism that govern these functions. So, nowadays, almost everyone uses some form of artificial intelligence, some form of ChatGPT or DeepSeek, Anthropic, Perplexity, so on and so forth. And these softwares, these programs are actually utilizing much of the research done in computational biology, and models like ACT-R and SOAR, which are quite common, they are used to explain memory retrieval, large language models, and machine learning, and aspects of autonomous technology, for example, drones and robotics, so on and so forth. So these are different aspects that contribute to real world applications because of neuroscience. So what I'm going to do is speak about ACT-R model. By the way, this is new territory for myself as well. I've mostly focused on cognitive neuroscience, neural networks, perception, and attention. And the reason I'm stepping here is because this is essentially the backbone of artificial intelligence, and this is something that is dominating and will continue to dominate technology in the coming years. So I think it's imperative that I go through this tough time and come out of the other end, inshallah, bi-idhnillah, successful. And of course, the idea is that we must dominate and conquer this field. Obviously, there are many powers, academic, technological, government, sociological, that will be against myself and against essentially anyone who more or less looks like me, speaks like me, and so on. In any case, put my trust in Allah, is Dhul Hijjah, and we will not have any fear or grieve over anything, because Allah is the best of all planners. Okay, so Act R, adaptive control of thought, rational. ACT-R is a cognitive architecture that models human cognition by using a set of programmable information processing mechanisms. So it's using a set of programmable information processing mechanisms. It is a theory of cognition implemented as a computer program, allowing researchers to predict and explain human behavior. So this is centered around the question of how we act, when we act, and an attempt at getting closer to the question of why we act in certain ways. Of course, I am of the opinion that it's merely impossible to explain the why without Allah, and it's not an opinion, it's actually a fact. But within this field, that is something to be established within the rules and the models and the knowledge at hand. Okay, so here with me I have Patricia Churchland's book, and it's an interesting book because it sets the tone for a philosophical discussion as well as a mathematical one and a neuroscientific one. I would say I barely understand 1%. I'll be very humble in admitting that. But in any case, I'm going to begin with chapter number 5, inshallah. It speaks about the hippocampus, and the idea here again is to not just read a book from back to front. That's not really my style. Rather, it's a case whereby you read a few chapters, few portions of a book, and you not necessarily compare it, but correspond it with another one. So, for example, I'm going to be reading right now, based off of Act R, Insights into Human Behavior. Now, I have another book here, which is called The Innate Mind. Picked it up fairly cheap. Secondhand bookshop, just randomly came across it. By random, I don't mean the conventional meaning. I mean something I did not expect, which resulted in something quite amazing. The amazing part is that this book actually speaks about Act R, right? Only if I am able to find more references. But anyway, so here we have Act R. I think it was somewhere here, this page. So Newell, so Newell talks about Surah. Okay, let's do this. Let's speak about Act R. I'm going to spend about 10 odd minutes on that. going to spend 10 odd minutes on Newell's Surah. He has a book called Cognition. I don't have it on here. I'll pull it out soon. He has an entire book on this. Once we're done with this, then we'll step into Churchill's work. So I think that's fair, inshallah. So, history of Akhtar, very quickly. Let's look at the history here. It's a cognitive architecture developed by John Robert Anderson and Christian Libier at Carnegie Mellon University. Controversial place. Like any cognitive architecture, Akhtar aims to define the basic and irreducible cognitive and perceptual operations that enable the human mind. In theory, each task that humans can perform should consist of a series of these discrete operations. Okay. Most of Akhtar's basic assumptions are also inspired by the progress of cognitive neuroscience, and Akhtar can be seen and described as a way of specifying how the brain itself is organized in a way that enables individual processing modules to produce cognition. So, as we go along, what I like to do is when I read something brand new, because this is not exactly brand new, but it's more of a thorough revision for myself. These aren't sticky notes exactly because they don't stick. These are more akin to a notepad, right? So the idea essentially here is to take a note of everything I read and how my brain works. Again, this is only because of Islam and the very limited knowledge I have about the Quran, which I need to go back to in terms of Surah Al-Baqarah, like this. Once I read something the first time, and anything that captures my attention, I store it quickly, a bit like a computer. And by a computer, I mean rewritable CDs. For those of you who are probably old enough to know, before USBs, before streaming, there used to be CDs, right? It was a round disc. So what would happen is if you had data on a disc, you can write it on another disc, and the way you would do it, it was record all the data and information on that disc, and then you take out the original disc with that data. Let's say it has music and pictures or Quran, and the Quran on that CD, the tray would pop out from the laptop or the tray on the CPU, and then you put the rewritable CD. It used to be called CDRW, right? And so you put the CDRW in the CD, you close it, and then the data is essentially copied onto the CD. So that's exactly what's happening, in a sense, not entirely, but in a sense, where much of the information I look into and read, I just capture it, keep it in my mind, and then I take a note here and I do my best to retain that information. And apart from this technique, diet is key. So what we'll do is look at Akhtar's actual structure, i.e. architecture, and understand this a bit more. I am on a Wikipedia page. Sometimes the Wikipedia is a bit off, so it's important to double check the references at the end. So far it's good. Of course, this is run by the CIA, but in any case, fit in the system to change the system, right? So this is what more or less the Akhtar architecture looks like. So you have declarative module, intentional module, Then you have goal buffer, retrieval buffer, sensory buffer, motor buffer, and then you have in the sensory buffers the auditory, visual, sensory modules. Then you have the motor. Then you have the retrieval, which is obviously the decisions you're making. Then you have the declarative, which is also in a sense vocal, oral, because even when you speak in your mind, it's your voice, right? So then you have the environment at the bottom. So you have the modules that's overarching the buffers. And then at the end you have the environment. So this is what I am speaking about. Hopefully, inshallah, you can see it. Right here. So what I'm going to do is hold it like this, because the good thing about a live stream is I don't need to edit. I'm going to, on a separate screen here, pick up a search result. Okay, why it's not coming up? Right, so this is what I would do. Okay, I'm just going to read it out anyway. And ensure that we understand what's going on. So I'm going to pull up the model here actually. It's going to be better for me. Right, so declarative memory stores facts and goals as knowledge chunks. Procedural memory stores productions. If this happens, then this will be the result. Those rules that specify how to achieve goals. Production rules. If then statements that define how a task can be completed when a specific condition is met. Okay. Buffers. Temporary storage locations that hold information during processing. Pattern matcher. Searches for production rules that match the current state of buffers. Okay, so these are this is a model to understand how we act and trying to get at the bottom of why we act in certain ways. It's interesting overall, if you ask me. It certainly caught my interest when I came across this. So this obviously requires a lot of deep diving. So I am cognizant of the time, so I'm just trying to make sure that everything is running smooth here. Okay, so far Act R is adaptive control of thought rationale. And the modules overarch the buffers, and then the environment is interacting, and there's an interplay between the environment and the buffers and the modules. Okay, and again, this was developed to understand how human beings think. Now, naturally, at least for me, I had a very potent question. The question was, how can it be that using such models, arguably complicated models, are needed to understand human thought? Why must I take into account a model? Why can't I just go about it arbitrarily? Oh, well, this trauma happened, therefore I had to, in a sense, rectify or fight with my intentions, and then buffers is, let's say, for example, sensory buffer. What I saw, what I heard was extremely traumatic. Now I'm going to interact with the environment as if it's going to traumatize, it's there to traumatize me. That's why a lot of people, especially those who take drugs and they become addictive and they try and get off those drugs. By drugs, I mean alcohol, cocaine, heroin, of course, meth. They're always on the edge when they're sober. And it's extremely difficult for them to return to that state that they originally were in. You see, the fitra is extremely powerful. Allah does not make mistakes. You look at the birds and other creatures in the sky. You look at sea snails and other creatures in the sea. You look at bacterium under a microscope that exists in our water, in the air, on our skin, so on and so forth. They all have a purpose. Now, once their purpose is disrupted, challenged, then there are consequences which are fairly brutal. Let me give you an example. Transgenderism. That's your example. Now, going back to Act R, the whole idea of Act R is to give us an understanding of the rationale, the reasoning behind our actions, intentions, thoughts, perspectives, decisions, and to a degree our opinions and how we learn. So, core principles. Rationality. Act R is based on the principle that the human mind operates in a rational and efficient manner. Modular. Act R consists of specialized processing modules that work together to coordinate information processing. Okay, I don't see any issue with that particular definition. Act R models can be simulated to make predictions about the human behavior and to explore different cognitive processes. Okay, so it's a model that can be incorporated in different models. Sorry, it's Act R exists so it can be implemented to make predict. Its implementation is to predict human behavior and explore different cognitive processes. Now, the question I have is, Act R explains which processes the best and weakest of them are ... So now I'm trying to understand at this point is the strengths and weaknesses, just like with any theory, any study, any hypotheses, there are strengths and weaknesses. So this is extremely important for our focus. Application: modeling human cognition. ACT-R can be used to model various cognitive processes such as memory, attention, and problem solving. So ACT-R, as far as my memory stretches, pun intended, to a large degree, it stores memory and it's able to release or utilize said memory in units. At least that's what I understood in this book I read back in April. So, distributed connectionism was a theory I came across in this book, and I like to use this to transition into Surah and see an explanation. So understanding human behavior, ACT-R can help explain why people make certain decisions and how they learn new skills. Can it explain? Okay, let's expose more. By the way, I've created a GPT called Brain Explorer. If you go on ChatGPT and you search Brain Explorer, it will come up. It's a picture of a multicolored human brain. And anything you put on that GPT, it will give you everything in a great length, great detail, fairly accurate. Obviously, double check the references. Everything to do with psychology, neuropsychology, neuroscience, the mathematics behind neuroscience, the controversies, the advice a student might need, or a direction a professor might need, and extremely powerful. Of course, you can go on the regular ChatGPT and do so, this, that. Give me this, do this, show me that. But these are prompts that are far more relevant that have been put on there. So, for example, you go on Brain Explorer and you simply type in everything I'm talking about now and what I will ask it. And inshallah, tomorrow we will discuss these 3 points I like to make on ACT-R, 3 points I like to make on Surah, and inshallah see where we go from there. So, can ACT-R explain why people make certain decisions? Okay. Next is developing cognitive models. ACT-R can be used as a foundation for developing cognitive models in various fields such as education, human-computer interaction. So now, developing cognitive models. Using ACT-R. I will do explain question mark here. So now I'm curious about these 3 things. Number 1, explain strengths and weaknesses. Number 2, can it explain human decision making? I don't think it can. It can give us a good understanding, but not an accurate breakdown, or should I say precise breakdown. Developing cognitive models using ACTAR explained with examples in education, and human-computer interaction. So that's ACTAR. Most basic surface level stuff. Now we'll move to SOAR. So, reading this particular book, came across something interesting here. And this might be slightly out of context, but bear with me. Hopefully it makes some sense, right? So, it talks about the biological aspect as well, right? So, let's start with SOAR first and foremost. SOAR is a cognitive architecture created by John Lard, Alan Newell, and Paul Rosenblum at Carnegie University, of course. Then People's. The goal of the SOAR project is to develop the fixed computational building blocks necessary for general intelligent agents that can perform a wide range of tasks to encode, use, and learn all types of knowledge to realize the full range of cognitive abilities found in humans, such as decision-making, problem-solving, planning, and natural language understanding. It's both a theory of what cognition is and a computational implementation of that theory. So it's an attempt at highlighting what cognition is, explaining it, and then taking those explanations, breaking them down computationally, i.e. mathematically, and then applying them systematically, i.e. implementing them, right? That's what it is. So since its beginning in 1983, John Lard's thesis, it has been widely used by AI researchers to create intelligent agents and cognitive models of different aspects of human behavior. The most current and comprehensive description of SOAR is the 2012 book, The SOAR Cognitive Architecture. So this is obviously a extremely lengthy and comprehensive breakdown Rosenblum continued to serve as a co-principal investigator after moving to Stanford, then to Southern California's Information Science Institute. It is now maintained and developed by John Lard's research group at University of Michigan. So, University of Michigan. Okay, interesting. So, I'm going to ask my GPT to explain this to me, because I cannot find a good definition on the Googles. Right. So our cognitive models general architecture, cognitive architecture. So SORA stands for State Operator Apply Results. Okay. Of course, these entail different definitions and different concepts one has to look into, right? So, sorry about that. I just had a really weird nerve that hit me. Just trying to check if there's any questions. No. Okay, so SOAR. SOAR is a unified theory of cognition aimed at modeling human problem solving, learning, and decision making. Core concept: state represents the current situation or environment the agent is in. Operator: possible actions that can be applied to the current state to change it. Right, so state represents the current situation or environment the agent is in. So let's say you're in a positive state, optimal state. Number 2 is operator, possible actions that can be applied to the current state to change it. Okay. Instantly I'm thinking of a lab, which is the state it would be in. Let's say it's in a good but not great state, and actions that can improve it. Apply: choosing and applying an operator to the current state. So choosing an action to the current state. Results: the outcome of applying the operator leading to a new state. Right, okay. Key features: goal-driven behavior uses goals and sub-goals to guide actions. So, like the example I gave of the mouse, that is in the Morris water maze example. There's a goal and a sub-goal. Goal is survival. Sub-goal would be safety. So finding a place of safety in order to survive. So if you Google Morris's water maze, you'll see it. How that circular tank has that platform and the mouse has to go on it. Number 2 is production rules. Uses if-then rules to make decisions. If I do this, then this might happen. If this action is applied this way, then this result will come. However, if it's applied in this way, then the result would be in the opposite direction, same direction, bidirectional, so on. Learning, also known as chunking, learns from experience by creating new rules based on successful problem solving. Problem spaces: abstract structures where states, operators, and goals exist. Interesting. Okay. So applications: AI, robotics, cognitive simulation, and human-computer interaction. Now, what's interesting is that I haven't made any lengthy notes in this case. Neither will I lambast, which is criticized at the moment. But what I'm going to do really and truly is ask GPT now that, hey, can you give me an explanation of how Surah is different to Akhtar, like pros and cons. So we'll do that tomorrow, inshallah. That's extremely important. So we have Surah versus Akhtar. So we have Surah versus Akhtar. Okay. Key differences. Similarities. Best overall model. So we're going to go bottom up. We're going to look at the best model, we're going to look at similarities, then after that key differences. Now, last but definitely not least, I think it's fair enough for me at this point to say that I'm not going to read this particular text right now. I'm going to save it for tomorrow. Inshallah, I'll do an earlier live stream, bi'ithnillah, and work on understanding this better, right? So, first and foremost, I'm gonna go back to Patricia Churchill and stuff very quickly here and just see if I can, in a sense, run through it. Yeah, I can't really go through it because I can see there's a reference to patient HM, Damasio, Squire, Zola Morgan. I mean, these are technical people, and I can't break it down. It would be extremely unfair if I try and do it in like 2-3 minutes. So I'll put this up for now, chapter 5, and certainly 100% inshallah we'll come back to this chapter and ensure that tomorrow we can, go into more detail, because this is really fascinating stuff, really important stuff. So if there's any questions, any comments, let me know. Before I leave, apparently the Gaza flotilla is fast approaching. They are mentioning 7th of June. Inshallah that arrives safe, although I am skeptical given the fact that it's celebrities on there and who's financing it, who allowed this, in a sense, civilian ship enter these territories. Those are the main questions I'm asking. And there's been a flood in Nigeria. In fact, it happened a few days ago. Some reports say about 80 people, some are saying about 200. Inna lillahi wa inna ilayhi raji'un. People are still fighting for aid. The company responsible for aid, and those are neither here or there. Of course, Zayushil funded, and it's a tragedy because it shouldn't be the case. Children are literally fighting each other over food. I've seen videos where kids are fighting for food and the hot food falls on top of their heads. It reminds me of some videos I've seen in Congo, not the fighting part, but the suffering part. And another attack on Pakistan is definitely imminent. Iran, I'm of the opinion, has nuclear weapons. And it's been recently stated by the FBI head, Kash Patel, that Epstein did deoxygenate himself, and they've seen the videos, even though the camera wasn't even working that day, and he was on watch of making sure he doesn't deoxygenate himself. So sort of scam, because when Epstein's theories were to come out, then the entire world will just go against the occupiers. So that, and a company called Palantir taking over America. By the way, I don't know what Palantir is, and I'm not even sure if all these reports are true. I mean, I'm sure it's just a technology company that gathers data, analyzes data, and ensures everything is safe, right? So their name's popping about. I think it's probably just another Bitcoin ice bucket challenge thing. So before I leave, I'd like to recite an ayah of the Quran. Popped into my head. Surah An-Naml. Surah An-Naml, ayah 62. أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. Excuse me. أما يجيب المضطر إذا دعاه ويكشف السوء ويجعلكم خلفاء الأرض أإله مع الله قليلا ما تذكرون. Sadaqallahu al-Azim. So this approximates to English as, or who listens to the soul distressed when it calls on him, state, and who relieves its suffering, operator, and makes you, mankind, inheritors of the earth, apply. Can there be another God besides Allah? Little is it that you heed. That's the result. So, really and truly, this basic cognitive model summarized in this ayah, in my view,